So just as we did before, it might be useful to start by dealing with the implication. So we're needed to negate this whole statement. But rather than jumping immediately into things, I'm going to start by rewriting that implication the exact same way we did before. I, again, find it easier to work with ands, ors, and nots more so than implications, although sometimes implications can be nice. So we're going to leave the negation on the outside, keep the inside the same, P and Q, or the thing in the second parentheses we would write as it's an implication, so we do not the first thing, so not P, or Q. So R or Q. And then we can use our double negation to simplify further, so we have not on the outside. P and Q, or P or R or Q. And now we need to distribute that negation. We could try to do some stuff on the inside. We'll talk about that after we distribute the negation, whether or not that would be a good or bad idea at this point. But I see that I have a negation and I have two different clauses here that I can write the negation next to and then switch the inside symbol, again using that De Morgan's law. So we get that this is equal to. So we get that this is equal to not the first thing, P and Q. Switch the inner symbol there, and then not the second thing, P or R or Q. And now we're going to use De Morgan's again, and we'll get not P or not Q, and we didn't mention this earlier. We'll actually talk a little bit about this in a little while in the course. When we have a negation and more than one or, you can actually do De Morgan's just sort of boost it up one more level. So we have P or R or Q. You can do not P and not R and not Q. Just negate everything and switch all of them. That works. We'll work on talking about how you might prove something like that later. But for now, let's just say, yep, it scales up at a reasonable level. And not Q. And now we got to try to figure out how to deal with this, because we could try to distribute the not P or not Q to everything, because we have something and something else, and distribute the second thing there. There are sometimes some smarter ways to do this. However, if we get stuck, we can always resort to sort of this brute force method. We'll just keep using rules and see what happens. So let's try and see what happens here. So I'm going to move this off to the side and then go up here. We're going to distribute. So we're going to distribute. There's two ways you can distribute here. You can either distribute, I'll mime it, this expression to all three of these, or you can distribute the second expression to the two things on the inside. I'm going to do the second one there because I find it a little easier. Sometimes it can be really hard to sort of munge through all these symbols though. So I'm going to actually switch the order of the symbols first to make it exactly like the rule we have above. So not P and not R and not Q and not P or not Q. This is this idea of commutativity. A times B is the same as B times A. We're doing that exact same thing here, but with ands instead of multiplications. And then we're going to distribute that huge chunk in the parentheses into the smaller thing. So this is equal to, we have the first thing, not P, and not R, and not Q, and not P, or the same exact thing, not P and not R and not Q, and not Q. And again, you might try to have been clever before this, but now maybe we can see there's something a bit suspicious about what's going on here. In the first statement, we have a not P and a not P, and in the second one, we have a not Q and a not Q. If you have a duplicated symbol, that symbol effectively means, look, if I say my name is Nick and my name is Nick, you might look at me like I'm crazy because why on earth would you say the same thing twice? So because of that, we can remove the redundant symbols, and we have not P and not R and not Q, or the second thing, which is not P and not R and not Q. When I say remove the redundant symbols, notice they didn't just cancel each other out. It's just that saying it twice is irrelevant. My name is Nick and my name is Nick as a single sentence is redundant, but I can't just cancel out the my name is Nick and say nothing at all, right? I still need to keep one of the instances of the thing I'm trying to say. And now if you look at this, this is a bit of a dumb statement. We have a whole bunch of garbage or the same whole bunch of garbage. That's A or A. And this is one of our identities. If you're just ORing something with itself, again, that's redundant information. You can remove one of those and it is exactly the same sentence. So we have that this is equal to not P and not R and not Q. And you might have been able to identify that earlier. If you really kind of stared at this expression, you might be able to come up with a reason as to why that can get reduced. I tend to find that sort of reasoning sometimes helpful, but oftentimes being able to do this manipulation when you do get stuck and cleverness doesn't strike you, I find a little bit more helpful when you're first learning these sort of things. So again, we probably could have been really clever and identified, oh yeah, somehow this stuff's going to cancel, and you can reason through all the different options and maybe try to get some of the rules involved to do that. Or you can just kind of do this brute force method that I did, and that also works equally as well.